So some of you have asked for a little bit of extra help with these questions. So I'm going to start with C and I'll go through and answer these step by step. First, x plus 2y. So here we have my working out. X plus 2y in reality is an extra addition. X plus y plus y. So we're adding quantities. And so therefore the rule that we're applying is that when we add quantities, we simply add the absolute uncertainties. So first thing we need to do, and I've got that separated on the left side of the paper, is the first thing we're going to do is actually work out this calculation. So if we take x, which is 18, plus 2y, and add them up together, we end up with 36. So now we've got the answer, we can now work on the uncertainties. Now the uncertainty in x plus 2y, the rule we're applying is that we're going to add the absolute uncertainties of x to 2 times the uncertainty in y. So we have 0.5 plus 0.4 plus 0.4. And that gives us an uncertainty of 1.3. Okay, so we can express that as 0.5 plus 0.4 plus 0.4, or simply 0.5 plus 2 times the uncertainty. So what we can do is just say that the uncertainty is the uncertainty in x plus the constant times the uncertainty in y. That's the rule you'd be applying. Our final answer is 36 plus or minus 1.3. Now note about significant figures. Really, ideally, if we look at the significant figures here, we've got 2, and here we've got 2, but this one does not have a decimal place. So really, we should stick to no decimal places. So 36.1 is more correct, but for the within reason, 36.0 plus or minus 1.3 is also okay. Question D. D is similar, but this time we are subtracting. Again, we've got 2x. Now 2x is the same as x plus x. So it's still an addition question. And then 2x minus 3y, well that's the same as y minus y minus y. So we're still dealing with the rule. What do we do when we're adding or subtracting uncertainties? We are adding and we are basically adding the uncertainty as well. Now the first thing you have to do is the calculation. So 2 times 18 minus 3 times 9 will give you 9. So that's your actual value. Okay, that would be 2x minus 3y. Our uncertainty would be 2 times 0.5, the constant, times the uncertainty in x, plus 3 times 0.4, 3 the constant, times the uncertainty in y, which gives us an answer of 2.2. And 9 is, why is this in one significant figure? Because 18 has no decimal places and we should stick to the smallest amount. So our final answer is 9 plus or minus 2, but to be honest, if you wrote 9.0 plus or minus 2.2, that is okay as well. Right, question E, which is simply x times y. Here we are multiplying uncertainties. So what we're doing is applying the rule fractional uncertainty in the total value is equal to the fractional uncertainty of the first value plus the fractional uncertainty in the second value. So the first thing we have to do is to actually work out x times y, which is 18 times 9. That gives us 162. So that is the value of xy. And now let's do the uncertainty in xy. Fractional uncertainty in xy, which is delta xy over 162, because that's actually the value of xy, would be equal to the fractional uncertainty in x, which is 0.5 over 18, plus the fractional uncertainty in y, which is 0.4 divided by 9. Now that gives us a value of 0.0722. But we now need to multiply that value by 162 to give us delta xy. And when we do that, when we multiply 162 times 0.0722, we end up with a value of 11.7. So our final answer is 162 plus or minus 11.7. But sticking to the number of decimal places here, we really shouldn't have a 0.7, and it's much neater to write 162 plus or minus 12. Sometimes there's a really strict adherence to the rule that uncertainty should be one significant figure. I don't think you need to do that, worry about that now, but that's why the answers in the booklet actually say 162 plus or minus 10, because that's one significant figure, but 12 is just fine. Okay, let's try the next one, which is x divided by y. So now in this calculation, you're going to do something completely different. You're simply going to take 18 divided by 9, which gives you 2. But our uncertainty calculation is actually the same, in the sense that we're still using the fractional uncertainty in delta x over y will be equal to the fractional uncertainty in x plus the fractional uncertainty in y. So these give you, once again, 0.0722. The difference is that now we're going to multiply that by 2, right? Not the number we had in the previous question, but now it's 2, because that's our value of x divided by y. And that will give us 0.144. When we write this down as a final answer, we end up with 2 plus or minus 0.14. That's a bit ludicrous, having no decimal places, because we would end up with nothing. So really what you should write is 2.0. I've squeezed that in there, 2.0 plus or minus 0.1. Our next question involves a power. We're doing x, y to the power of a half. So first step is to actually work out what x, y to the power of half is. 18 times 9 to the power of a half gives you 12.73 and a few other numbers, but this will do for now. Now the uncertainty in x, y to the half, we're going to apply the rule fractional uncertainty in x, y to the half. So that means this unknown divided by 12.73, which is the value of x, y to the power of a half. Okay, that's the fractional uncertainty in x, y to the power of a half, will be equal to the power. Now check this out. The power, which is a half, times the uncertainty in x times y. Now, does that look familiar? Because we did that a few questions back. It's the uncertainty in xy divided by the value of xy. So that would be question E, right? If you remember from question E, delta xy was 12 and xy was 162. So now if we multiply that by the power, which is a half, we will end up with an uncertainty of 0.47, which we're going to round up to a sensible amount, one decimal place, which would be 12.7 plus or minus 0.5. The tricky bit, I think, with this question is that you have to take a step back and just work out x, y, xy, because we've removed the power from this idea. The power goes here. Anyway, have a go at that one and reflect. Now we're going to work out the uncertainty in x times y cubed. Now there's two stages to this. We've got on the one hand the fact that we're cubing y, and then secondly that we're adding it, we're multiplying it to x. So the first thing we do is actually work out that calculation. 18 times 9 cubed, which should give us 13,122. That bit's fairly straightforward. Now to work out the uncertainty in xy cubed, we need to think about two different things. We need to think of this as a multiplication between two terms, x and y, right? So we're going to have to consider the uncertainty in x and the uncertainty in y cubed. And then secondly, we need to figure out what the uncertainty of y cubed is first. So let's do that first. Let's look at y cubed. The uncertainty in y cubed over y cubed, right? So that means the fractional uncertainty in y cubed would be equal to the power, which is 3, times the uncertainty in y over y. Now, I hope that sinks in. You might have to think about it for a minute. But if you remember from the question, that y is 9. So 9 cubed is equal to 729. So delta y cubed would be equal to 3 times 0.4 over 9, 0.4 being the uncertainty in y, and this 9 is y. So 3 times that gives you 0.133. Now we need to multiply this 0.133 by 729 to give us our uncertainty in y cubed. Okay, so now we've got the uncertainty in this bit. But now we need to think about x, because it's x times y cubed. So what we have to do finally is find the fractional uncertainty in x and add it to the fractional uncertainty of y cubed, which we worked out in the previous one. So in the previous question here, we've got 97.133 over 729. Right, so that's delta y cubed over y cubed plus the uncertainty in x over x, 0.5 over 18. And that will be equal to the uncertainty in x y cubed over 13122. So we just work that out, and we should end up with an answer of 2,111. Which we can round up to 1 or 2 significant figures. It's fine. Quite frankly, if you get this far, I'll be very happy with that as a good start. So the final answer is 13,122 plus or minus 2,100 or 2,000, more or less. But that was a tricky one. But no doubt with a bit of practice, you'll be fine.